Not everyone will necessarily agree with the central argument of this book. In the end, research on the nose continues to be in flux. Discoveries are going to be made after this publication. Maybe these discoveries will shed new light on the themes in this book, either further strengthening its claims or sounding discordant notes. After all, the book must end where the future of olfaction begins. Here's looking at you, kid. Introduction. Nosedive. We begin with an experiment. Hold your nose closed with your fingers, then chew a jelly bean. It will taste sweet, but not much else. Now, release your nostrils, swallow, and breathe out gently. Suddenly, the intense fruity note of the jelly bean, ranging from strawberry to citrus, will capture your attention. This is flavor as an olfactory phenomenon. You may be surprised to learn that humans are excellent at discriminating between several hundreds of thousands of smells, especially as different flavor components in food and drink. We do not have a good scientific explanation for how the brain makes sense of all these scents. Smells seduce or repel us, make us feel relaxed or stressed. However, we do not comprehend how the human brain creates and gives them meaning. Perhaps, for this reason, the sense of smell is hopelessly misunderstood and often misrepresented. This book addresses popular misconceptions associated with the human sense of smell and explores new research that will likely change your views on what your nose picks up for your brain to process and your mind to perceive. By analyzing what and how scientists know about smell, we revisit a classic question in sensory perception. What does the nose tell the brain? And how does the brain understand it? While the answer remains elusive, this book offers a contemporary philosophical and historical journey into this as yet unresolved neuroscientific puzzle. In this exploration, Smellosophy identifies the uncertainties and missing knowledge in our current thinking about odor perception, including our theoretical understanding of the perceptual dimensions of smell and their links to cognition. It is the perfect arena for competing ideas about the senses as our access to reality, and it is time to consider smell as a new model of how the brain represents sensory information, and for the nature of perception in general. Smell is a highly variable sensation. Variation occurs among people, but also in an individual's encounter. Its versatility and qualitative experience lends olfaction an air of subjectivity. Because of this, some do not believe the nose to be a trustworthy messenger of objective reality. This view, however, now stands corrected. Your sense of smell is much more credible than you think. Recent insights into olfaction open up a new way to think about perception, including the origins of objectivity in our subjective experience. The firm opposition between subjective and objective dimensions of the senses originates in orthodox philosophical ideas that did not incorporate knowledge about the brain. Contemporary theories of mind and brain continue with a limited perspective, as they seldom look further than what meets the eye. The persistent paradigm for the study of the senses is vision. This is not surprising. Philosophical traditions centered on understanding in terms of seeing things. Scientists have learned more about the visual pathway than any other sense. In the late 1950s and 1960s, advances in research on the visual system resulted in a mapping approach to the brain that continues to define the field of neuroscience, as well as the growing cross-disciplinary debates about the philosophical implications of its findings. The visual paradigm centers on spatial topology and assumes that external stimuli are represented by localized neural patterns in particular functional areas. Accordingly, specialized regions of the brain create and process our perception of particular features, such as the orientation, shape, or color of an object. This organizing principle of the brain has also been found in other sensory systems, such as audition. Similarly, if we were to look into your brain and see activity in a specific part of the auditory area in the cerebral cortex, we would know whether you are experiencing a high or low-pitched tone. Perceptions of color in vision and sound in audition are based on one chief causal parameter: the wavelength of the electromagnetic spectrum of light in vision and air pressure waves.